Okay, so today we're tackling just one source. It's the DVDO C5-1B 4K PTZ AI camera. And our mission really is to figure out if this camera, which costs what, around $2,500, if it's genuinely the next step for things like automated lecture capture, telemedicine, or if it's maybe just a pricey PTZ with some fancy extras. This deep dive is kind of about seeing if that price tag holds up.
Yeah, and what's really interesting, I think, is how the camera's design almost declares, that maybe the human camera operator's time is, well, maybe numbered in these environments. The immediate justification, the thing they lead with, is that core capability.
Hmm.
You get true 4K UHD video up to 60 frames per second, and it has this built-in AI for human detection. So it's designed to deliver really high-res video, but also to sort of think for itself.
Okay, let's talk clarity then. It starts with that SOI CMOS sensor, right? But, anyone who's worked in a lecture hall knows lighting can be a nightmare. You mentioned 3D DNR. For the listener maybe wrestling with those tricky lighting situations, how does that actually translate into a better image day to day?
Well, the 3D DNR, this 3D noise reduction, working with the super high signal-to-noise ratio, it means even in low light, the camera is actively cleaning up the picture in real time. So that translates directly into, professional-looking video, even under those harsh fluorescent lights or where you've got weird shadows. And they also talk about this leading autofocus technology, described as fast, accurate, and stable. That just makes sure the clarity holds, even if the person speaking is moving around a lot.
Right, makes sense. So we have a sharp image, but how do you actually manage a camera that can do all this? A 25x optical zoom, that sounds massive. Is that overkill for, say, a smaller classroom, maybe just 5 meters deep? Are you paying for zoom you won't use?
I wouldn't say overkill if you think about scalability and repeatability. That 25x zoom, plus the pretty wide 59.2-degree angle lens, it means this one camera could potentially handle a small conference room or a big auditorium. But the real efficiency boost comes from the 255 available presets. You can program it so it instantly snaps to the podium or the whiteboard or maybe a specific audience section, all with just one command. And that big pan tilt range, 110 degrees side to side, 30 degrees up and down, that's just to make sure you can cover every corner if you do have a larger space.
Capturing the image is one thing, but getting it where it needs to go, this is where the systems integrators probably lean in, right? The integration part. The specs say the C5-1B handles simultaneous output across HDMI, SDI, USB 2.0, and the LAN port. That's 4 different ways out at once.
And that is the secret sauce, really, for these hybrid setups we see everywhere now. This simultaneous output lets it do dual stream, a mainstream, and a substream. So your mainstream could be that high-quality 4K, maybe for recording locally, for archival. While the substream is lower bandwidth, perfect for sending out live, to Zoom, Teams, or whatever streaming platform. Doing both at once just makes workflows so much simpler.
And the LAN port handles power over Ethernet, PoE, so one cable for power control and the video feed. That definitely cuts down on installation complexity and cost, which maybe helps justify that initial $2,500 price a bit more.
Absolutely. But the real game changer, I think, is the AI. This is where it aims to fully replace that dedicated camera operator. It uses its own processor and algorithms for intelligent tracking.
Okay, the source mentions real-time tracking can follow someone walking up to, what, 6 miles per hour? So if you've got a really energetic professor who suddenly dashes over to the whiteboard, the camera should theoretically stay right with them.
That speed rating suggests it's robust enough for those dynamic situations, yeah, like active teaching or maybe live medical demos. The other key mode is zone tracking. This lets you set up, I think it's up to 4 distinct areas. So say the instructor walks off the main stage into an area you don't want tracked. The camera doesn't just get lost. It can either jump to a preset view or just wait until the person comes back into one of the defined zones.
Right, and that automation ties directly back to those use cases. Online education, lecture capture, telemedicine. It basically aims to eliminate the ongoing cost of manual camera work.
And just to add another layer to the integration, the camera can also act as an HDMI encoder and decoder, which means you could send high-quality video over your standard gigabit Ethernet network, avoiding potentially long or difficult HDMI cable runs. Plus, critically, it supports all the key protocols you'd expect: RTSP, RTMP for streaming, OAN and VIF for compatibility, and network VLS for control. So it should integrate into existing campus control systems, like Crestron or whatever custom setup they have.
Okay, so the main takeaway here seems to be that the DVDO C5-1B isn't just about capturing video. It's really a whole system designed to manage, automate, and distribute high-quality streams. The automation itself might be the primary value, maybe even more than just the raw image quality.
Exactly, which leads to kind of a provocative thought for you, the listener, to consider.
Hmm.
Given how complex you can make these AI tracking zones, and you've got that huge physical movement range, plus 255 presets per camera, how might integrating, say, just four of these cameras fundamentally change how you'd even design the physical layout of a modern auditorium or a teaching space? Something to
Whoa.
think about.